Okay, so today we're going to do matrix multiplication, but it's when we have a matrix by another matrix. Before we looked at, we looked at scalar multiplication. So if you had something like this, you multiply that scalar, so you'd have that, whatever. But this one, we're actually going to get a matrix times another matrix. And for that to happen, there has to be certain things have to be in place for you to be able to multiply two matrices. So what we have, if we have this certain matrix, so we're just calling it matrix A there, and we're going to multiply it with matrix B. They would have their order, whatever they have. So they would have their rows by columns, and B would have its own rows and columns. So if you're able to multiply it, these two numbers, so the columns of matrix A have to be the same amount as the rows in matrix B, in the second matrix. And when they are equal, that is what we call defined, and that it can happen. It means you can multiply. And once you multiply, so maybe we shouldn't have called that there. Sometimes we call it just AB. So we've multiplied them together and we get an answer. Now the answer's order will have the number of rows from the first matrix and the number of columns from the second matrix. That will become the new order of the answer. Now, when they ask you, can this happen? They might give you two matrices and say, can they be multiplied? You have to answer with this yellow statement. It has to be, and that's why it's in yellow. You know how I often put the fill in the blanks, what you need to write? Well, yellow, you have to write it. So say I was going to write it, I'd say the number of columns in the first matrix. Now, it might not be A, it might be something else, but in the first matrix must equal the rows in the second matrix. That first sentence or part is the vital thing. You will not get the mark if they ask you to explain why they can be multiplied. See how I wrote they were equal up here? A lot of kids write that. That's not going to cut it. They're not going to give you the mark. You're right that those two have to be the same, but it's too lazy. It's not explaining it properly. All right, so if you have a look here, we've done a couple of examples. So we've said this matrix here has an order of a 2 by 3. It's got 2 rows. And B is a 3 by 1. And then you have an answer, or you've got C, that's a 2 by 2. So can I multiply A by B? I'm looking at these examples here. Well, let's have a look. If it has an order of a 2 by 3 and B is a 3 by 1, yes, we can, because those two are equal. And you will result in another matrix. So what they might call that the product matrix, because it's the result of times in 2 together. So it will have an order of a 2 and by 1. It'll be a 2 by 1 when you think. So once again, we've just copied that and we've said that's just the rule written out again. So you will have to learn how to multiply two matrices that are of 2 by 2, like a small amount. Not real big ones, but you do have to manually know how to do it, and we're going to do that in a minute. But here's a few questions down here. If we look at this example, if A is this matrix, B, and so on, which of the following are defined, and if they are, what's their order? So it's handy just to write the orders under all of them so that it makes it a bit easier to see whether they are. Now, can A, B be multiplied? No, because these two don't equal, so it's not defined. Can B, A be multiplied? See how when you put B first, so B was a 1 by 2 and A was a 2 by 2. Was a 2 by 2. It can be multiplied, can't it? Because those two equal. Yes? Can you see how AB was not possible, but BA was possible? Can you see that? So order is extremely important in matrix multiplication. In normal maths, it doesn't matter if you go 3 by 2 or 2 by 3, does it? They both equal 6. Yes? In matrices, that is not the case. So that is not the rule here, because sometimes it can be done and sometimes it won't be done. And sometimes they might both be able to be done, but it'll be a different answer. It's not the same thing. So order is extremely important for that. And so we see that. And that's what that is saying down here, that AB does not necessarily mean that it's BA. All right, so we're going to go on and look at how we manually multiply matrices. So what you're going to see is when you have two matrices, what I want you to do, originally you should look at what you've got to begin with and make sure that it's defined. So if I was multiplying these two up the top here, is it defined? Yes, isn't it? Yeah? These two are equal, and will this be my answer? Yes? So what you should do is draw out a template of what your answer is going to look like. Now, we said it would be a 2 by 2. And maybe what you do is have those spots there so that you can see what you should have. There should be an answer, 2 rows and 2 columns, like that. So when we go to do matrix multiplication, what you're going to do is you're going to go, sometimes we say run and dive. So we're going to take the first row and multiply it with the first column. So we run and dive. But if you have a look, you can see that A gets multiplied with E and B will get multiplied with G. So can you see that there? So here's the BG and there's the A and the E. They will get added together and become this answer in that spot of the thing. All right, now then we would go again. We take the, if we do run and dive, we would go run across the first row and down the second column. So you can see A got times with F here and B got times with H. So see how here, I'm in row 1 and column 2, is that correct? So see how I'm going to put the answer in row 1, column 2. Okay? Now, when I'm down here, I'm in row 2, column 1. Is that true? Yeah? So if I was, I'm going to rub that out. So say I was in that row, just to show you, I'm in here. I'm in row 2, so it'll be this row with column 1. So those two get multiplied with those two, and then you add them together to get the answer. All right, so let's practice that with these little matrices here. So first I'm going to work out if they can be done. So this is a 1 by 3, and what's B? A 3 by 1. Excellent. So they are defined, so I can do it. And will this be my order? Yes. So what will my order be? A 1 by 1. So I'm going to have a 1 by 1. So I'm just going to make a spot. It'd be 1 row and 1 column. So essentially it's going to be 1 number in there. So what we do normally, we go run and dive. So 1 is going to get multiplied with 2. See, this 1 with that 2. Then 2 will get multiplied with 4, plus 3 will get multiplied with 1. And then you just tidy that up, because that would be, what's that? That's 2 plus 8 plus 3. That will equal 13. And there's your 1 by 1 answer. Okay? So this will make it, you need to learn this skill, because when you get a bit of problem solving, bit harder questions, they're going to draw on the fact that you know how to do this manually. So if we look at the next one, we have A. If I'm going to multiply these two, I've got a 2 by 2 and a 2 by 1. Okay, I'm just going through the process. So yes, it's equal, so I can do it. Like, you don't want to waste your time if you can't do it. Just say, that's a bit of a hassle. And my answer is going to be a 2 by 1. So I'm going to draw up a matrix that has 2 rows and 1 column. So it's going to have 2 spots as such, like that. So let's go and do the first one. So first row, first column will be, so a 1 times 2 plus 0 times 3. And then I might do the second row and the first column, and it'll be a 2 by 2 plus a 3 by 3. Okay, then you just go tidy that up. So what would 2 plus 0 be? 2. And 4 plus, what's that, 4 plus 9? It would be 13. Okay? You can do them on the calculator. Of course you could, and get the answer, and that's what you should do if you're not asked to show anything, but we need to practice this. So while you're here and you've got time, practice doing it as much as possible and check on your calculator if you got the answer right, to make sure that you're practicing the calculator skill too. All right, so let's have another look at this last one. Now, it doesn't matter if we have letters or numbers. Who cares? So we've got a 2 by 2 and a 2 by 1. So we'll think about it first. Yes, it's defined, so I can do it. I can do it because the columns in the columns in the first matrix equal the rows in the second. But anyway, what order will we have? We're going to have a 2 by 1. So you're going to have a 2 rows by 1. Okay, so we've got that ready. And if we go run and dive, so first row, first column would be 1 times x plus 3 times y. And then I'll go again, and I go second row and the column. So that will be 2 times x plus negative 4 times y. All right, so when we're tidying that up, I've essentially got x plus 3y. I can't add them together, can I? You can't add, you can only add like terms. So you just got to leave it like that. And this bottom one will be 2x minus 4y. So essentially the elements for this one, that's one element and that's 2. So there's your 2 elements in your 2 by 1 matrix. So it doesn't matter that you have letters. And that's something they can get you to do, because your calculator might not do something if it's manually like that. All right, so let's have a look at this exam question so that you're aware of what's going to happen, in your exams. So it says the 4 matrices are shown below. Which of the following matrix is not defined? So not defined means you can't multiply them together. So put your orders underneath. So that one's a 3 by 1, this one's a 2 by 3, that one's a 1 by 2, and this one's a 3 by 3. It can make it easier to see. Now, can you do W by Y? Yeah, you can, can't you? There was 2 ones there, yes? So that one's okay, we can do this. Can we do X first? So X would be a 2 by 3, and then by a W, which is a 3 by 1. Can that one be done? Yep. Y by, what are we doing? Y by X. So a Y is a 1 by 2 by X, which is a 2 by 3. Yep, that one can be done. Z by W, yes, that can be done. And hopefully this last one cannot be done, which we've got a Z, which is Z is a 3 by 3 by Y, which is a 1 by 2. Yeah, they can't be done, can they? So your answer is this one. All right, so you can see how they can ask that in the exam. Now, that was from 2015, so a few years ago, but that's question 2, so that's not meant to be that hard, okay? So when you're thinking, yeah, good, sweet, easy, well, it's not meant to be too hard. All right, the table below shows the number of coins saved in a money box. So here you've got a 5-cent piece, and you've got 15 of them. You've got 32 10-cent pieces, 20 48s, and 24 50-cent pieces. Now, this is what you've got to do when you get these ones. They're going to ask you the matrix product, so that means when you times 2 together, that displays the total number of coins and the total value of these coins. So, what can you see? Essentially, do you want 2 answers there? Yeah? Don't you want total coins? Isn't that what they're saying? And total amount, would you think, that it adds up to? Is that fair to say? Yeah? So could you see, the only way I could display that is if I have either 2 by 1, or I could have it written like this, total coins and total amount. So, which would be a 1 by 2. Could you see how that's the only really way I could display 2 numbers? Do you understand that? Yeah? So when you look at these, you can start to check whether you're going to get an answer. So this one are 1 by 4 and a 4 by 1. Is that going to give you, what type of answer is that going to give you? It's going to give you a 1 by 1, isn't it? Yeah? So you can definitely say that's out. What about the next one? If I look at B, this is a 1 by 4 going with a 4 by 2. Can I multiply them? Yeah. And what will my answer be? A 1 by 2. So this one looks okay, doesn't it? Sorry. It gives me a 1 by 2, which is one of my options. So let's have a look at what it does when you do it. Now, if you've got a 1 by 2, that's going to be this guy here, look like this. So you would go run and dive. So what it's going to do, it's going to add up 15 plus 32 plus 48 plus 24. Can you see that? Because every time you times something by 1, don't you get itself? So if you times this, it would have been up here, it would have been 15 times 1 plus blah, blah, 32 times 1 and so on. So that first answer, what's it doing? It's adding up all the coins, isn't it? It'll give you total number of coins. Now, if I go again and I go run and dive, that's going to say 15 times 5, yeah? And then it'll go plus 32 times 10. Is that adding up the value? Can you see how that's adding up all the value? It'd be 15 times 5 plus, and isn't there 15 5-cent pieces and 32 10-cent pieces? Can you see that's giving you the answer there? So this one's they're a bit harder. So in the end, this is the answer, and hopefully the rest don't work. The rest won't make sense and if you go through it. But yeah, that one is question 4. It is a little bit harder, but that's why you have to practice the manual multiplication so that you can pick this up. All right. Let's have a look at this one. It says the price in dollars of 3 different size televisions for 3 different brands of a major retail store is shown below. The retailer is about to discount product A. So product A is going to get 10%. So these guys are going to get 10%. What is it? They're going to discount, sorry. Okay, B are going to, so they're all getting discounted. But anyway, B's going to have a 25% discount. And C is going to be, C is going to be a 15% discount. Okay, if you're discounting something, what essentially are you timesing it by? So if you get a 10% discount, what do you times the whole number by? 0.9, good. You're timesing it by 0.9. You're actually getting 90% of the item, like the price of the item. What about 25%? You would be timesing it by 0.75, yeah? And what would this one be? 0.85, good. So we want to see, first of all, we want to see those numbers. And really, can you see that's not happening there, here, and these last three are doing it. So at least we've got rid of two. Now, look at what the question asks. Which of the following matrix equations would give the discount price in dollars for the three different size TVs for the three different brands? So you really essentially need the prices all listed out again, which would be, you need a 3x3 for sure. You have to have three rows and three elements. So look at this. With this one was a 3x3 going with a 3x1. Is it going to give you a 3x3 answer? Is it? No, it's not, is it? It's going to give you a 3x1. So get rid of that guy. Now, these two are obviously going to give a 3x3 answer. Now, let's have a look at what makes them different. So you're going to get, when you answer it, you'll get a 3x3. Oops. So think about it. If I'm getting the answer for this first one, I'm going to go row 1 by column 1 to get it. So I'll go row 1 by column 1. Can you see when I do that, I will be doing 0.9 times 800 plus 0 times 1200 plus 0 times 2000. So essentially, all that's going to be put in here is 0.9 times 800. Now that will give you the 10% discount for that one, won't it? So that looks good. Now, if I went and did this answer here, okay, so that would be this row by this column. The 0.9 is going to affect this 750. Do I want this 750 to be times by 0.9? No. So let's get rid of this now. So hopefully, if you do this one, we'll get it. So we know when we do this by that, the 0.9 is going to affect that 8. Now, what about when we do this first row with the second column? 750 is going to be times by 0.75. Is that what we want? Yes. So you can see this is the answer. Okay? So they're a little bit difficult. You have to work through these. These are what will make you a little bit better on this. All right, and then let's just go through the last little bit is what I've already mentioned to you. In exam tip, comes from the examiners when they first introduced matrices, but it's still constantly coming up. Students need to be able to articulate why two matrices may not be conformable for multiplication. What that means is you have to give two reasons, or you have to give a reason. It's because if they can't be multiplied, because the columns in the first do not match the rows in the second matrix. That yellow, remember at the very beginning? I said the yellow thing? That's what they're saying. And they said many students have illustrated poor understanding of the need of the number of columns in the first need, and that's just what I said. You need to be able to write that down. So you can copy the little yellow, that's fine. All right?